we're going to discuss recursion again, but this part is not a recursive part. This is just a data structures beginning to a Towers of Hanoi problem, where we have a limited amount of towers from start to destination, and in this case we have two auxiliary towers. These arrays represent the places that we can hold the rings on the towers. So we have the start tower, the auxiliary 1 tower, the auxiliary 2 tower, and the destination tower with 6 positions for 6 rings. Um, Now we have a function called move. This is the most basic atomic operation in the Powers of Hanoi algorithm. And what it does is first we have a temporary variable storing the index of the the start variable, the highest position of the start array, and then after that we make that same position where we're at on the first tower, and we're gonna use well, that start tower or that peg 1, peg 2. We're gonna use temp to store the top of peg 1. We're going to make peg 1 0, technically popped off of peg 1. And then we're going to use a while loop to let the ring fall all the way down to the first position. And peg 2 now equals that temporary variable we set at the beginning. Um, this is a class. We're going to call um, our object board, and we're going to initialize the start peg with a ring with size 3, a ring with size 2, and a ring with size 1. And the first move is the the two first pegs to start in auxiliary 1, and the highest position is index 2. Now let's print the start and the auxiliary pegs. Okay. Oh, I'm sorry. Hold on, just to initialize it and show you it runs the same way. I get my eggs. Okay. So 3, 2, 1, that's the nice organized tower on the first peg. Now let's look at A1, our destination for the moment. 0, 0, 0. Great, that looks fine. Now start. After we move 1 peg. 3, 2, 0. Where did it go? Let's see. Great, it's on the second peg. So that's my introduction to Towers of Hanoi through class objects.